So the first thing we're going to do, we have our part. This is for first milling machine project. So I'm going to take the file and I'm just going to lightly knock over the corners so the part will sit flat in the vise. There we go. Now, put this part in the vise. First thing I'm going to do, we're going to make sure the vise is clean. No chips down in the vise. I'm going to use parallels to get the part up off the floor of the vise so I can reach it with the cutter. Now, what we're using here is an angle lock vise and a vertical knee mill. A lot of times you'll hear these referred to as a universal knee mill because, well, they're universal. They can do a lot of different things. There's a lot of different attachments available for them. And one of the other generic names for it is a Bridgeport because the original manufacturer was Bridgeport Machines. Now, a ton of different makers got involved with this and made them and put different names on them. And they're all basically the same. You have left to right handle, which is X-axis. You have forward and back, which is Y, this handle. You have a knee that you can raise and lower. And you have a quill that you can raise and lower to drill holes. And on the side is usually a brake. Now, if this machine won't turn on for you, a couple things to keep an eye on is the E-stop out. You push in the E-stop, it cuts power to the machine. You release the E-stop, you twist, and it pops out. Now, the machine forward and reverse, you normally run it in forward. If it does not want to turn on, gently lift up on this brake and then gently let it down. It sticks in the down position on pretty much all of these machines, so the machine won't turn on with the brake engaged. So just lightly push up, gently let down, and it should run. Some of these machines are going to have, this is a electronically variable speed head. You change the speed by turning this knob. Hear it speed up and slow down. And I'm going to set this at about 1,000 RPM. Some machines have a crank on the side that you have to have the machine running to adjust speed, and some have a belt you have to change inside the head. So ask your instructor for which one it is and take notes. Now to tighten the vise, I just have a wrench here, but usually you're going to have a vise handle. Make sure to take it off before you use the machine. Another thing, down on the left-hand side is an oiler. Push down, hold it for a second or two, and let go. And that'll pump oil into the working parts of the machine. Do that every time you come up to the machine. If you go for lunch, come back, do it again. It needs it every couple of hours. Now, over here on the right, I have a digital readout. No reference, it stops blinking. As I move the table, it moves with the table. And this tracks the position of the table. You have to set this. Don't think to be turned it on and it has some numbers on it that it means anything. Because this thing can be reset at any point in this travel, including 60 inches, which this machine can't travel 60 inches. So I'll show you how to set that in class a little more. So now what we're going to do is we're going to put a tool in the machine. Now, this is a collet. These come in different sizes. There's a 1/8 inch one. This is a 1/2 inch. We're going to use this. This is a drill chuck. Its name should imply something to you. It's for drilling. It is not the Holden end mill. This will ruin this drill chuck. Every drill chuck in this building has problems, and it's because people hold end mills in them and it destroys them. It is not for end mills. Now, I have a 4-flute end mill and I have a 2-flute end mill. If you look at the end, 1, 2, 3, 4 versus 1, 2. The softer the material, the less teeth you want to use. So 2 flute for aluminum, 4 flute for steel. Now this has a keyway in it, and with the machine off, you feel inside, you'll feel a keyway. Slide it in, rotate it, and eventually you'll catch the keyway, and then on top there's a bolt called a drawbar. And that's it right there. We're going to go ahead and we're going to tighten up, draw that collet in, and tighten it. So I run it down by hand as far as I can go. I hold the brake down and I tighten the wrench. So I laid out my work so I can see where to cut to. Now this is only an approximate. This is not exact. I'm just getting a number to shoot for. I don't expect this to be perfect. This is just a reference. It's like the yellow lines on the side of the road. They're there for reference, they're not there for you to drive on. So I got the part on parallels to get it good and tight, and the cut line is off the side of the vise, so I have clearance for the cutter. So now I'm going to crank the table over, and I'm going to crank the knee up. Now I can run this quill out to try to reach the work. This quill has about 5 inches of travel, but the farther out the quill is, the weaker it is, the harder it's going to be to achieve tolerance or any kind of surface finish. So, for instance, that's way too much. So I'm going to run the quill back up, tighten the quill lock, leave it sticking out about 1 inch, and I'm going to crank the knee up to bring the work to the cutter instead of the cutter to the work. And this is good cardiovascular workout. Turn this thing a couple hundred times a day. Make sure to use one arm for half and one arm for the other half so you don't look like a fiddler crab. So, I'm going to bring my cutter over the work without the work touching, or the cutter touching the work, and I crank the knee up so that I'm just below this line right here. This is as far as the cutter can cut. This is the end of the actual cutter. This is all shank up here. So I'm going to turn it into forward at 1,000 RPM. And I'm going to slowly feed the work to the cutter. And when I get contact, hear it squealing, I'm going to stop. I'm not going to go any further. I'm not going to back up. A lot of students get nervous, and when they touch the cutter to the work, they back up. Well, I need to use the cutter to machine the work. You don't back up, you leave it right there. Now I'm going to use my y-axis, and I'm going to feed across the work. Now, I barely contacted the work. If we come around to the side, we'll see a shiny area right here at the bottom and a duller saw cut area above it. That all needs to be saw cut. One thing we can do to make this more obvious, we can take the marker and we can draw on it. So I'm going to zero my readout so I can keep track of what I'm doing. X is left to right, so I'm going to hit the black button for X. I'm going to enter 0, and then I'm going to hit enter, and that zeroes it out. I'm going to come in about 15 thousandths, 0.015 inches, which is right there. Don't worry about that last digit. I'm going to turn the machine on, and I'm going to feed the cutter across. Now, the direction of rotation, you want this thing running forward, but the direction of rotation versus which way you're feeding the table will actually get you a little bit different finish. One of these is called climb milling, and one of these is called conventional milling. Also, if you spread a little bit of oil on here, you'll get a better finish and the chips won't stick as much, but there's more cleanup then. But that's a really nice finish. That's a really good finish. So what I'm going to do is I'm going to re-zero my readout. Black button again, 0, enter. So now this is the edge of my part. The tool and the part are the same. If I move the tool in, the part's going to get shorter. If I move the tool away, well, I can't add material, but it's further away. So now what I'm going to do, using the quill, raise it up, lock it again, and I'm going to come down. Because I have to cut a notch in the part, because the part needs to look like, we started with this, with each end had extra saw cut material. We machined this off. So now what we're going to do, we have a nice factory, not factory, but machine cut edge. We're going to cut that shoulder. So I'm going to come over the part, less than the distance I want to move total. So I want a 1/2 inch wide, a 0.500 wide shoulder. So I'm going to come in 450 thousandths. And it's negative because that 0, that side of the Cartesian coordinate is x0, that side is x positive. Sorry, x negative is that side, x positive is that side. So I'm going to come over the part, and I'm going to crank up. Now, I'm going to move really slow when I get close, and I'm watching for the magic marker to get rubbed off. And this is touching off the work. So I'm going to touch off the top. I'm going to locate the top of the part with the bottom of the cutter, and it just started to machine a little bit of it. And if you notice, it only machined in one area. The part's not perfectly flat. There's a few thousandths of variation. So I'm going to come over to my knee, and this black knurled knob right here locks this dial in place. So I'm going to grab the dial, and I'm going to twist the knob. And some student who is much stronger than me tightened this up, apparently. So I loosen the knob, I spin it around to 0, and then I very lightly being the operative word, tighten the knurled knob. Okay, so I zeroed my dial with my cutter at the top of the work. So now what I'm going to do is I'm going to crank up, I don't know, about 30 thousandths, and I'm going to slowly feed across the work. And I lock the knees, or lock the x-axis so the table won't move. I crank up 20 to 50. I'm going to feed back. I crank up to 80. I'm going to feed back. 100. I'm going to feed back. 120. So I'm going 20 to 30 thousandths per pass. I go to 150. And you notice I'm not restarting at 0. I'm totaling as I go. So I'm at 150 thousandths, 170 thousandths, 195, 210, 230, 240, and I'm going to come up to the other dial here, x-axis. I'm going to move it into about 470. Feed across. I'm going to feed back to my start without changing anything. I'm going to come up to 0.5 on the x-axis. I'm going to move up my last 10 thousandths on the knee to 250. And I'm going to feed across. This is climb milling So the cutter rotation wants to pull the work through the cutter. I'm going to feed it slow, and since this cutter is a 1/2 inch wide, my slot's 1/2 inch wide, I'm going to come back to a smaller number and feed back where I came from to make sure that there isn't a little lip left. So now, turn the machine off, and I should have a really nice finish. A flat shoulder, a flat bottom, and if you look, there's a bad burr right here. This is normal in machining. Anytime you cut metal, you're going to make chips, and you're going to raise a burr. Even the act of trying to remove a burr is going to raise a burr. But here we go. We got it machined, we got it machined, we got it machined. So what I can do now is take the part out of the vise. Once again, make sure the machine's off. Make sure the chips are out of the way. You probably shouldn't touch these with your bare hands. Use a brush. And while I have the machine out, or the part out of the machine, I'm going to knock that edge over. I'm going to hold the file at about a 45, and I'm going to file just enough to break that edge. I don't want to actually eat into the part at all. I'm going to knock it off on all sides. If I leave a burr, it's going to sit in the vise a little bit crooked, and it's going to affect my tolerances. Tolerance being how much bigger or smaller the part can be and how square it has to be and all that. So there we go. Part is partway done. So I'm going to put this back in the vise, stick it out the side. Now why am I sticking out the side? Well, I have to machine the end of the part. If I had it in the middle, I couldn't get to it with a cutter. Run the quill back down again. And you notice how I have a lot of the cutter sticking out the bottom? This cutter's longer than I need, but it's what I had available and sharp. So rather than cut with the lower part of the cutter, I cut with the upper part. Cutters tend to get dull in the end first, so the area up here tends to be sharper. Also, this will squeal and chatter less, which is another lecture. So I move away from the part on X, move in on Y, so I'm over the center, I crank up slowly, into the part, and I face it off. Now that just barely machined anything, so I'm going to go in about 5 thousandths. Without setting the readout, I can tell where I am by looking at the dial. Little red line on the machine, the dial says 80, so if I go to 5 less, I can feed across and I'll take 5 thousandths off. And that started to clean it up. So now I'm going to go ahead and I'm going to measure this. Now I'm going to wiggle this caliper and make sure it's seated properly. I'm reading 1 inch 540 thousandths on the dial. I didn't take it off and read it because now it moved. I read it while it was on the part. So, black button, 1.540, enter. This is the positive side of X, that's the negative, so this should get smaller now. If it doesn't, go back to that location and change it to negative. And it's getting smaller, so I'm safe. So I'm going to take a nice light cut, clean it up, and I'm going to go ahead and I'm going to remeasure it. And I'm reading 1.527. So I'm going to take 2 thousandths off and bring that down to 1.510. With my cutter positioned behind the part, and I'm going to slowly feed in. This is, once again, this is climb milling. This will give me the best finish. And I'm going to go ahead and I'm going to measure it again. And I'm reading 1.512. Interesting. Remember, calipers are plus or minus about 5 thousandths on a good day. The readout's pretty good, but the machine may not be. The cutter's not necessarily as sharp as I want. You're going to get some variation from measurement to measurement. So this is why we try to sneak up on the work. I always measure a lot before we get to the final size. So we'll go to 505. And I'm going to measure again. And we got 1.508. Now I'm going to go ahead and I'm going to cut it to size. So there we go. 1.5 on the nose, hopefully. So now what I'm going to do is I'm going to take this out and I'm going to put the drill chuck in. And we're going to drill a hole in the part. To change the collet, push down on the brake, put the wrench on that bolt, and push back. When it starts to turn freely, take the wrench, smack the drawbar on top. It'll break it free. You'll be able to pull the cutter out and then unwind, and the collet will fall out eventually. There we go. Okay, so we got the collet out. One thing I want to bring up, don't draw the drawbar all the way out. Don't unwind it all the way and then pick it up and drop it down onto the collet. It's going to damage the threads in both. And if you do that in a professional shop, they're probably going to fire you. So I got a drill chuck, same exact system. Spin it around till you find the keyway, slides in, tighten the drawbar by hand as far as you can tighten it, and then tighten up your hand on the brake. Now, one thing I should probably add, this is a bad habit I developed, leaving the caliper on the machine. The chips and the filth fall into the caliper. They end up getting in the gear rack and the caliper stops working. Calipers really should be kept behind the machine on the table. Also, that's easy to pick up, but that's easy to walk by and knock off. Push them back. So I'm going to crank the knee down, and I'm going to find my location. Now, keep in mind, that 0 I had, or that 1.500 I had, that was the edge of the cutter, not the center of the spindle. So I have to actually find my location. Again, this is an edge finder. Some of these are full diameter out here, they're 1/2 inch diameter. This one's a 0.2 inch diameter, and it works by kicking over. I'm going to put it in the drill chuck, tighten it, forward, now if you have a good eye, you're going to see it wobbling up top, and that's because somebody damaged the drill chuck by holding an end mill in it. But see the bottom wobbling? I'm going to come up, and as I get closer, it's going to wobble less and less, and then it's going to kick out. And hopefully you can hear it ticking a little bit and see it kick over. This one's pretty worn, so it's not kicking very much. But when it first kicks out, that's what you're worried about. So when it kicks out, you can draw it up, turn the machine off, 0 readout. Now this is the edge of the edge finder. The edge finder has diameter, it has radius, it has size. This isn't the center of the spindle. We want the center of the spindle. Well, the edge finder is 0.2 inch diameter at the end. So we need to move in its radius to get to the center. So we're going to move in 0.1 inches. And once again, don't worry about that 10th digit, the last one. So now what we're going to do, we're going to do the same for y-axis. And I'm using the back jaw because the back jaw doesn't move. And it kicked out. So, Y, 0, enter. So here we go. So now what we're going to do, we're going to come in the amount of the distance required on the print, which is 0.5 on Y, in this case 0.5 negative, because we're on the lower quadrant.
It's not. Focusing here.
Now, the next thing we're going to do, we're going to use a center drill. This is a regular drill bit. This is a center drill. These long flutes and this long length, when this hits the work, it's going to walk. So we're going to use a center drill, which is stubby, and we're going to put a cone in the work that we're then going to follow with the drill bit. Now, a drop of oil will make this go a lot better. And I'm turning this, it's running true. Tighten it up. Give it a drop of oil. I'll let it dig in just a little bit. I'm going to push down, and every so often I'll back off a little bit. Make sure the chip breaks. Some of that oil I put on it get in there. And I'm going to go down into the cone of the center drill, because the cone is what does the work, which is this portion here. This doesn't do any good, and that point down there doesn't do any good. So now, put some oil on the drill. I'm going to crank the knee down, and I'm going to grab the drill bit on the solid portion, which is called the shank. I'm not going to grab it on the gullies. That's called the flutes. And I'm going to make sure my parallels aren't underneath where the hole is going to be. Now, as chips start getting long, just back off and they'll break. If the chips stop coming up out of the hole, stop and back up and go back down. And feel free to add a little bit of oil. And I'm through the part. So now I reverse. I'm done. I'll go ahead and I'll put the drill bit back in the box it came from after cleaning the chips off. Put the center drill, edge finder back, and then I'll go ahead and I'll clean the machine. When you clean the machine, use a brush, sweep everything down to the floor, and then clean the floor up. Chips are going to get into these T-slots. Don't stick your finger in the T-slot and push them out. Cut. Take a paper towel or a rag, jam it down in, and drag it out. And one thing to be careful about, when you're cleaning the machine, always, always, always push in the E-stop. That way it can't possibly turn on. If you want to wear gloves when cleaning the machine, that's fine. But only when cleaning the machine with the E-stop pushed in.